Greg, can you hear me? Awesome. I saw the thumbs up.
Roger, Roger.
So for those of you joining us currently, this is part two of a series. Our first part was with Greg himself here and Jason Lichman, which is also running this chat channel. They both did a entire series or an entire episode based on the idea of using Fusion 360 to design a part, as well as leading into using Xometry to manufacture that part. In this second part series, we're actually going to work it a little differently. We're going to look at Xometry for being able to take work and increase your shop revenue, and then how to use Fusion 360 to program those parts. So I do have Greg currently on the Zoom meeting with us. He is the applications engineer for Xometry directly. He will be giving us a little bit of a bio here shortly, but the idea of this whole webinar is to show you not only can you use Xometry as a source of income for your business, but you can also use Fusion 360 to program those parts. A little bit of what we have going on today on our agenda. Start out with our intros with myself and Greg. Then we're going to jump into what Xometry is and how they can help your machine shop. And then we're going to go ahead and take a job from Xometry's web portal and manufacture that using Fusion 360. Lastly, we will wrap this up with the Q&A in the last 10 minutes. So jumping into this out the get-go, Greg, do you want to go ahead and introduce yourself?
Yeah, absolutely. And thanks so much, Phil. Just very excited to be here and actually learn more about Fusion 360 and what it can do as well. But I'm here obviously advocating for Xometry. Jason and I talked about how we can be used to make parts, but we also have this huge supplier network of vetted manufacturers. And I hope that some of you that are attending are interested in part of the Xometry supplier network, or are actually part of our network right now. And that's how this manufacturing is fulfilled. So we're actually going to do some live demoing of that. Also joined with me on the chat side, if you have any questions, we have Casey Bennett from Xometry as well, and she is part of our partner team here, working with our manufacturers. Anything Xometry related, please feel free to reach out. And I know Jason is moderating on the Fusion 360 side. So we're really excited to get talking. Phil, anything that you want to touch base on before I run in? Actually, I got something to touch base with you. You've been a Xometry partner before, right?
I was an Xometry partner prior to actually taking my job at Autodesk. So I am very familiar with being able to take work from Xometry's website, or as I should say, Xometry. I do pronounce that wrong. There is no X, as I've been scolded for the last week. I have very much on a lot of occasions taken work from Xometry's website. In my case, I tended to use it as filler work, not a full-blown supplier, but I do know a lot of people do that. And we all have times of the year where it gets slow. It's nice to just go on, have it pre-quoted, take your work and go right to manufacturing and ship it out. However, in my time, we didn't have some neat features that we're going to touch on with their website, being able to purchase tools and material from what you're getting paid on that job. So you basically have no overhead cost when it comes to manufacturing the parts, other than your time and labor in your work center. So outside of that, I do want to mention, ideally, we do have a question and answer bar. If any of you have questions at any time, feel free to ask those in there. Jason is the one monitoring that. He could stop us throughout this demo if there's something specific to what's going on.
Awesome. All right, so I'm going to steal the screen then here. So I will take over. And what I want to do in the next 8-10 minutes or so is just actually go over what Xometry is. So you guys should see that recap slide. Is that right?
Correct.
Awesome. Okay. So just to recap again, we had a part one to the series. This is the world that I live in, where I work with designers, engineers every single day. I'm reading drawings. I work in over a dozen different manufacturing processes. But Jason and I walked through, a scenario where we were designing a multi-part assembly, using the quote and actually 3D print some prototypes, and ultimately move to where we could actually make some aluminum CNC machine prototypes. So you can definitely check that out. I know that's on Fusion 360's YouTube page, and Xometry also has it on a blog link. But I made a nice little GIF of that to show you that it was a really fun design-centric approach. And just for Xometry itself, like I said, we have over a dozen different manufacturing technologies. We make a ton of parts from all different types of businesses. So whether you're a Fortune 100 aerospace business that you're looking for a custom titanium CNC machine part, fifth axis with 17 helicoils, anodized, die pen inspected. We could do that. To, hey, I need a bracket. Let's make it done. And you could go ahead and make that as well. So additive, subtractive, EDM sheet metal work. We do molding and casting. We even do some lighter assemblies, I think of mechanical assemblies. And we really are your full supply chain service. And that has to do with, not just our front end of the instant quoting, but also the manufacturing network. So I won't go into the live demo. We may go into a Q&A if there's direct Q&A question on this, but the Xometry platform does allow people to upload a 3D model directly to our interface, and it quotes out instantly in different technologies. So you can go and toggle from, like, for example, a 3D printed SLA accurate clear view to a 3D print SLS part, to a CNC machine part seamlessly as you change and edit features. And you could add features, finishes, even upload a drawing directly to this. It provides pricing updates immediately as you're changing different variables. So it's very transparent on what's going on, like how price is driven by different features and finishes. And it helps you make a decision when you're working through that pre-purchase stage. But how do we make these parts? Well, we are actually connected to over 5,000 manufacturers globally. And since we are US founded and US based, over 3,000 of those manufacturers are in the USA. These are mostly CNC machine shops and sheet metal fabricators. We do also have, for example, die and tool shops and 3D printing services as well. But the vast majority of these are folks that are machining parts, because the skill is in that leadership in the shops. A lot of small business machine shops are sub 20 people, and they're owned by the best machinists there. So you have this highly talented ownership, and we're able to pair the work that is purchased through Xometry with those suppliers on our network that best fit that. And we're going to go over this in a little bit more detail when we run live on Phil's side, showing how you can actually go and review work on Xometry's job board once you're accepted as a Xometry partner. Just a note here, we do have a European network. So we have Xometry Europe, so it's xometry.de, it's xometry.com for the Americas. And both of us also have access to other international supply chains as well through the Xometry network. So we truly are a global manufacturing market. So this is part 2. This is about that manufacturing supplier experience. We have 3 main categories, or 3 main columns of the value add that we have for our suppliers. Phil touched base on this. We're your earning advocate, or I like to call it, we are your storefront. So we are jobs on demand. There is a job board where you can actually go and look at work, and the job board that you see up there, you'll see a price that you'll get paid, and that is already earned work. It's already purchased. The customer is on, not just on the hook, they've actually purchased this, and it's looking for a manufacturer. You're able to take a look at that on demand, and you're able to see jobs every single day as they refresh and populate and new opportunities come up. We also have an amazing community, and our partner team, including Casey, who's on this chat here, if you have any questions for Casey. But we have continuous technical and customer support. We have expert machinists, expert fabricators, expert tool makers actually on staff to talk with our manufacturing partners if something comes up, like say there's a job or a situation that they need to change. And actually, Phil, I think you had experience, right, where it was just like, hey, I just realized I don't have a gauge to check this thread. Sometimes we do a quick drop ship to send a thread gauge to our
I've
partners.
personally had that happen a couple of times where I've literally said to Xometry directly, I said, hey, I'd love to take this job, but this thread gauge may cost me a couple $100 and it's uneconomical for me to do that. They, in most cases, have reached right out to me and went, hey, we'll send you one, or we adjusted the job a little bit to help incorporate that cost. So again, very friendly, very fast responsive times on all of that.
Yeah, and even like we have a full QA facility out in our Gaithersburg, Maryland factory. So we actually have a lot of parts come into Gaithersburg, especially as new partners are being onboarded, because they'll have a lot of their work will actually go through a secondary QA at our own facility. and it is decked out. CMM, digital comparators, virtual CMM, which is actually the wildest thing I've seen. And every single type of manual gauge, profilometer, spectrometer, we have it there to help qualify and inspect. So sometimes even if there's like, for example, a specific thread, we can also do a slight adjustment and make sure that work gets back to our facility before going out to the customer to qualify that thread with gauge.
Greg,
And then,
we did
go
kind of
ahead.
just get a question
Mhm.
coming through, and I don't want to throw
Yeah.
you off, but it
Oh no,
does
sure.
relate to the manufacturing side of things.
Mhm.
Customer's question is can you be a Xometry supplier for FDM and SLS printing on top of manufacturing?
Yeah, absolutely. So all of our manufacturing processes are throughout our network, and I'll jump into this in a second here. Actually, this I have a whole page on exclusive member benefits, but that's actually the icing on the cake here. But just real quick, because it's a great segue to this next one. Work.xometry.com is where you're going to start. So if you're interested in becoming a supplier, you're going to go there. There's a sign in. There's basically a vetting workflow to go through. So that's going to be things like signing NDAs, creating your profile, and then we will actually reach out and work through a vetting process with you. There definitely is different demands for what type of work it is. So if you're sitting here and you're like, hey, I'm an ITAR supplier, I do aerospace and defense parts, and I'm looking to get more work, you may move a little bit further up on the resume pile there, because we are always getting more and more ITAR work coming in through Xometry's network. In fact, we've also been able to take some of our top performing partners and help sponsor their ITAR registration to bring them up into that more into that type of work, because we always are seeing that demand, because at Xometry's instant quoting site, ITAR work is literally a checkbox. It makes it so incredibly easy to get ITAR quotes. It's insane. Folks in the aerospace defense industry really like that. Um, but as I said, we're your storefront, so ever-present customer acquisition. We have this amazing supplier community. So actually, it's a community of your peers on the Xometry marketplace, where you could have forums, you get updates. Even if you have a question on specific jobs, it's a place where you actually go and speak live with from manufacturer to manufacturer, or with someone on our supplier team. We have a finishing network. So if say you are a shop, but you don't really have a hard coat anodize or plater or someone like that, you can actually use Xometry's finishing network to line up the tail end of the job. So like post machine finishing. You could definitely use our finishing network for that, powder coating, even like serialization, stamping, laser marks. It's a great resource for you. And they turn around quickly, because they're used to the type of Xometry work comes in. So a lot of times you get a quote in 2 hours, and the turn time is usually sub 48 hours. We also have other ways where you can get more different types of revenue. So the RFQ marketplace is a new way to connect directly with buyers on Xometry. And right now you can go if you need aluminum, if you need acetal, if you need stainless steels, if you need end mills, cutting tools, drills, calipers, Xometry Supplies is there. And an added benefit of being a Xometry partner, so our supplier, is that with Xometry Supplies, we have free 2-day shipping on all orders over $50. So we automatically upgrade. So say it was going to take 5 days ground, we automatically upgrade that to 2-day shipping. It takes 1 or 2 days ground, it stays at that ground. But either way, we have a mechanism to make sure that things flow smoother for you. And like I said, icing on the cake here. This is actually one of the coolest things, because I've been in a shop where I've worked in shops before where I just know cash is king, payroll is king, and even getting a job is sometimes scary, because you have to drop money up front to purchase your tools and supplies to make that work, even though you know it's profitable. Sometimes it's scary just to have to drop cash up front. So being a Xometry supplier, as a vetted partner on our network, we have some really cool options. So once you ship, we pay 4 weeks on that Friday. So no more staged shipping periods. It's just 4 weeks on the Friday after you ship is when you get paid for that work. We also have this Xometry Advance card, which gives you up to 30% available line of credit on what you're earning. So say you take a job for $1,000, you have up to $300 line of credit that you use immediately anywhere Visa's accepted, to essentially pay against your earnings there. So say you buy $200 of supplies, you'll get paid $800 at the tail end of the job completion, but you're not needing to drop that cash immediately from your current bank account. And it's not a credit card. It doesn't affect your credit score. It's based off upfront upcoming earnings. And we'll show a little bit of this on the live side, but on our finance page now, we are previewing FastPay, which is going to be super exciting. But it's one of those systems as well where you, versus that 4 weeks from Friday, you can actually get paid within a few business days for for a very small percent. But it's a very quick system. So if you do need to work through some cash flow, it's another way. But this is something that's all part of the Xometry marketplace and Xometry supplier experience. So I think, Phil, I want you to talk about your experience. I actually want to show you, we want to show some of this job board live. So yeah, and then also I'm just super excited to see the cam, because every time we've practiced a couple times, every time I watch how fast it moves is like jaw dropping how fast you're able to program. So I'm really excited to learn how you can actually use Fusion 360 Cam to help program against different parts here. And we're going to move to a live version of this, but if when you move to live, I want to slow down and just kind of highlight some of these cool things here, so we can highlight some of these details. But I'll give the board back to you, my friend.
Yeah, no problem. So we did have another question come through
Oh yeah.
that was a pretty good question, and I actually know kind of the answer to this myself. Somebody's question is in the event that they have used Xometry for quoting, what did happen is that finishing, such as anodizing and that, the price has been substantially different. Being somebody that has manufactured parts and sent it out for coatings, I will tell you, an example, an anodizer that I worked with, it was $175 for the tank. Whatever fits in the tank, it's still $175. If I had 100 parts or one part, it's still $175. So depending on who you work with your finishing can really make a big difference when it comes down to that. I also know that a lot of parts that I did, we would avoid anodizing on, and I'm not saying anything bad about it. It's if you get anodized parts from multiple different suppliers, the anodizing coating can be dramatically different in shades. Is that correct, Greg?
So there's usually a mill detail that's paired with anodize, and we do have on our FAQ. I don't have the detail on top of my head right now of what a standard is, and it does regulate a little bit of what to expect from a type 2 or type 3 hard coat of different stages of finish. Definitely type 2 black is probably one of the most common finishes paired with 6061 aluminum. That's definitely very common there. And if you are looking for a supplier, again, Xometry's finishing network, it's available to all right now. It's more streamlined being a manufacturing partner, but you can actually use the finishing network right now if you are looking for a specific finisher or plater, and they are very competitive and very quick turn.
So I've actually done that a couple times with parts where I sent it
Mm-hmm.
to a Xometry recommended anodizer. And the nice thing is once I completed the manufacturing side and I shipped my job to their recommended
Mm-hmm.
anodizer, it actually closed out the job on my end. So I didn't have to ship to an anodizer, get the anodizer to ship back to me, and then send the parts to Xometry. I could actually just create the chain and my anodizer would ship it straight to Xometry because they're so familiar with the process and the quality and what it takes to get to that point. I would still have my quality control
Mm-hmm.
precursor checks, which we'll go over, but it worked out very well.
That's awesome, and I mean I think it's very good. It's based on your locality, and we really do you really do build relationships with your different platers, finishers, and I know some of our folks, the finishers are actually able to box up and as you said ship on your behalf, so you get the package list shipping label. But yeah, we have a part here. So I don't have the mouse control. I know you have the mouse control, but I just wanted to show some things here. So this starts you off on the job board, right? So this is, you're signed in, you are Phil. In the upper right-hand corner, I see Phil right there. And you see a couple available jobs. So this is one work. This is work that when you press accept, so if this is work that looks good for you, so you're basically looking at that lead time and the scope of the project. How many am I making? Is the price, does it fit me in my shop? You can take that work and it's instant purchase order. This is what you'll get paid. This is what you have. We even have a match score. So based off your previous work, that's a score in yellow there, is based off what you previously done. Like we think is about this much of a match. And the more work you do like that, the better it'll get matched. We actually learn from your experience and try to put at the top for you what we think is going to be a best fit for you. Um, and some of the cool things here. So we'll go to the download in a second, but can you show the 3D view real quick?
Yeah, no problem.
And always look at the back of the part. So that's a word of advice, because sometimes it's a heat sink on the back or something kind of crazy there. This one's not crazy, but this part may actually look familiar. So this is a part that Jason and I walked through on the first part of the webinar. So now we're going to bring it into reality. And Phil, I'm going to give you the mic now, but I did want to show, like, this is, if that looks familiar, there's a reason for it. It is the part that we previously worked on the design stage of. So now it's been purchased, 5 of them, aluminum 6061. Well, let's see what it takes to manufacture it.
Yeah, so kind of jumping into this, great thing about the 3D viewer is I don't have to download a file yet. I can quickly look at something like this part in my lower left-hand corner. I can see rough dimensions for stock sizes. I can look around, make sure the backside of the part, as Greg said, is kosher. I mean, in this case, I don't have a drawing or a print to work off of, so I don't have to worry about anything hidden. So outside of anything on this part, I, in my opinion, would take this part all day long. And from a quick glance, it might be a good strategy to use a lathe. And then if you do have that fancy mill turn, possibly going lathe into mill turn. So let's go ahead and close this out and go back to my job board. One thing that 73% match score, all of those judging me out there, that's before I bought that fancy mill turn machine. So Xometry still thinks that I have a mill and just a lathe in my backyard. I moved up to a little bigger facility. So let's go ahead and look at the offer on this one directly. From here, I'm going to go ahead and accept my offer. In this case, just like he said, this is my job number. This is my tracking and everything inside of Xometry's website. It's going to go ahead and move me over to my current work next so that I could see that job on my personal board and manage everything going on inside of Xometry. Outside of that, I can also start to get an idea of material. So again, nice thing is here right out the get-go, it does say material ordered. This is basically a small version or a watered down ERP. So the first step Xometry wants me to know is, did I order material for this? Well, I do have the rough dimensions, roughly 2.5 round stock might be a good thing. Let's go ahead and go over to my material quick buy. It already brought up my 6061 T6. Let's go to round bar, and I want 2.5 OD. I need 5 parts. So let's just go ahead and order 1 foot. Outside of that, cost me $5.40 for that bar. I can add this to my cart. And I think Greg already mentioned this. I do get 2-day shipping for free, correct?
Yeah, so you'll get 2-day shipping on orders over $50, but this will probably still be pretty quick. And you're gonna put 12 there for the length.
Oh,
'Cause
I'm
I think
sorry.
this is
12. Did I screw
you got a
that
little
up?
yeah. Yeah.
So $27, still completely reasonable on a $650 job by all
Yeah.
means. Outside of that, one thing you guys will notice here is I do have a Xometry Advanced card. So my current balance is about $5,000. So Greg, correct me if I'm wrong. I can buy my material and my tools using this money right here, correct?
Correct. So the Xometry Advanced card, it's like, it's not a credit card, but I mean, it works exactly like a credit card. It's, you can swipe it. You have a number that you plug in, and it's a physical card that you apply for. So up on the finances tab, so you can see at the upper left, you have job board, current workshop, finances. That's going to be where you could review your balance and also apply for that card if you become part of the Xometry network. Phil, you got me saying Xometry now, by the
Yep.
way.
It's
Thank you
contagious.
for this.
You're
I've
welcome.
only been saying Xometry for 6 years, but now it's been butchered here.
Maybe we could change it to XYZ Xometry.
XY Xometry, Zetotry.
But yeah, so jumping back into this, let's go ahead and say we ordered our material, and well, my material came in at this point. We can go ahead and start production on our job. So Xometry does like the ability to see where you're at in the job, where it lies, because this is a direct relation to when your ship date is. I've personally had times where you get material the day it's supposed to ship, and I'm getting phone calls and emails from them wondering what's going on. They're very understandable with that. So jumping from here, let's go ahead and move over to Fusion 360. In this case, I actually did not download my model yet, so let's go ahead and do that first. I'm going to go ahead and go back to my current work, and I'm going to pull that model in. So you can see I have a couple other jobs currently on my board. Might want to buckle down because I think I missed the date on this one, Greg. I would have got a lot of bad phone calls.
This is the story of a dev environment, guys.
Correct. Yeah. So I'm going to go ahead and just click step, and you're going to see it's going to download my step in model, or my STP model for Fusion 360. So let's go ahead and now jump over into my Fusion 360 and upload that model to our cloud.
And
so
while you're while you're uploading that, so we have the reason why you're seeing step files is it's kind of a universal file format. So if we read my most most CAD and most CAM out there, so even if the customer uploaded IPT or CAP part or PRT or solid part file, we are converting that to a step. And that's what you're going to be able to see because it makes it more universal, so more partners can work through that job. It's also a note, so if you are a designer, you're used to doing stuff like model-based definition and PMI, I'm super excited about it as well. But not all shops are online with the ability to read part modeling information. So we usually are going to be requiring a drawing to accompany things like thread holes, surface finish callouts beyond 125 RA. Inspection, looking for inspection reports, we definitely need a drawing to know what we're inspecting too. So any features that are beyond just the cut general tolerances, we do require a drawing from our customers for.
So, kind of jumping back into my part now that I accepted my job and everything, first thing I kind of like to do on a part is I like to do an accessibility analysis. What accessibility analysis is going to show me anywhere that's undercutting. So, very easily, the green surface is accessible for re-access, going into the red area, which would not be accessible. Again, you can do this from multiple different angles if you like, front or back. Again, you can see I can access everything back the other way. I do have this hard part line between the top and the bottom of my model. So that's going to be a good transition point. However, we are going to turn this on a lathe. So that point's not going to cause a lot of problems with what I'm doing. From here, I'm going to go ahead and now jump over into the design area to the manufacture area. This allows me to start to set up my tool pathing and my programming of this part. So right out the get-go in Fusion 360, you're going to see a couple of different things here. One, I always have to have a setup, and two, I have tabs across the top of my screen for different manufacturing styles. I know we did get an FDM question earlier. We do have the ability to do additive slicing inside of Fusion 360, depending on your machine. But to start with, I'm going to sit in milling. Even though we're going to do this as a turning operation, it's not going to make a difference out the get-go. So right here from this beginning point, I'm going to switch from milling to turn mill. And then I like to personally change my stock. So let's go to a fixed size cylinder and utilize that. So currently my cylinder is pointed in reference to my world coordinates. So ideally, would I have to go back and change everything in design? Not inside of Fusion 360. I can actually define whatever I want for my Z and my X. In this case, it actually automatically snapped to the outside cylinder radius of my part.
So when you do that, so when you change the coordinates for how you're oriented in your machine designs and the manufacturing, it's not going to change how it's oriented within its assembly or anything that is, I guess, upstream on the design process.
Correct. I'm leaving the part exactly where it is. I'm just defining my G54 offset or whatever you use for work offset without modifying its current location. So
Awesome.
very fast. And the nice thing about this is a lot of people will see is I'll be able to do multiple operations in one file, keeping everything uniform and together. One more thing I am going to do, let's go ahead. My stock diameter actually automatically rounded me up to that 2.5 that I had. My length here for one slug, I do have a good amount to remove from the front. And on that backside, I may not have quite enough to part off. So let's go ahead and up our length a little bit. And then lastly, I'm going to go ahead and say offset from front. And let's go ahead and offset this roughly 20 thou so I can make a real clean cut across there. Actually, now thinking about it, let's bump it up to 0625 because that chop saw or that bandsaw that you may have for cutting material may not cut the straightest at the moment. So currently I have everything set in my setup. I'm going to go ahead and apply some tool paths here. You can notice how it moved me to the turning tab. However, I'm going to cheat the system. I do have this nice template pre-created ahead of time, and this was never designed for this part, but I can simply use a template to come in and do some machining. I did get an error on a couple of these tool paths, and what you're seeing is that blue area is the profile that it thinks it's the part. One thing it's not seeing is those tangs, right, Greg?
Yeah, it's like there's something missing there. You're gonna give a quick shave there.
Yeah, so let's go back and edit that real quick. And we have this fancy little button to say spun profile. Well, what spun profile is going to do is it's actually going to take that geometry and spin it a full 360 degrees and generate that now blue area that is my full part. So instead of splitting my model or creating a DXF based off, one little area of this, I can actually automatically spin my part and create that geometry. One thing that did happen here is my facing cycle automatically came in. It is set to a 40 thou step over, and it did recognize that 0625 material. Another couple of things that happened, I'm going to go ahead and switch to a top view so we can get a little better understanding of this, is we're going to come in and we're going to rough the OD stock down to the outside diameter. Lastly, we can go ahead and do a finished profile, which also traces around my part and goes past the back of my model. And lastly, I do have the part off here for flipping my part over. One thing you may be questioning yourself right now is, in the case of this part, can I turn the surface all the way back? Greg, what do you think?
I'm sure you can. You just got to you probably need to change the tooltip. But so what I'm seeing though is that yellow is going to be the outcome, right? So that's going to be the blank that you create on this. And so you're seeing that there's a difference where once that taper starts going, you're still going straight. So like, how can you dig in a little bit deeper and get more contour?
Correct. Fusion 360 has the ability to do radial and axial grooving. What is radial and axial grooving? I like to refer to it as undercutting, or being able to get into those areas that in most cases you might be switching tools to use something like a grooving tool or things of that nature. So out the get-go, I'm going to go ahead and stay with that 80-degree rougher to give you an idea of what's happening. Is Fusion 360 is looking at the angle of the tool for clearance, so it's still not crashing into my part, but I still have this nasty little bit here to rough out, correct? Jumping
Let's go
out
deeper.
of what's that?
We have to go deeper.
Well, we have to change our tool clearance. So real quickly here, I have the idea. Let's go back and pull in a different tool. Let's look at, instead of a CNMT right-handed rougher, let's go for something that's more or less a 135 type of cleanup tool. So I do have a VNMT in my library. Nice thing about this library here is we do have a cloud to store tools in. I also have a Fusion local library with sample tools so that maybe you have an additional seat one of your employees can learn without going through and messing up everything that you have here. So I'm going to grab that 135 tool, and then I'm going to go ahead and hit OK. And now you're going to see that
Nice.
follows that nice clean profile all the way around. From that, I do need to swap my tool into my cleanup cycle. I also need to turn on my axial and radial grooving so that that tool makes it all the way around. Again, I used a template to get to where I'm going very quickly and get about 80% of the way there, and then I can come back and make some changes. One other thing that Fusion 360 is doing for me is it's giving me a warning. And the warning is the lead out was modified because of gouging. So it even looked at my roughing profile and then warned me that it had to make a change because that tool's going to actually collide with that roughing stock. I can edit this to get rid of it. I like to leave it there for demonstration purposes. So let's go ahead and simulate this tool now, and let's see what we get for a part. I'm going to go ahead and hit play, and you're going to go watch this as it does its facing cycle. It swapped out tools. It went to my nice cleanup tool, and now it's doing that outside roughing. We're going in from that weird angle, and we're doing that undercutting. Lastly, we're going to come back around, and we're going to go and do one clean swipe all the way around. One comparison a lot of you may be seeing at this time is I have like a green, a gray, and a blue surface. Well, the green is cut to size within 3 thou tolerance. The blue is still material that needs to be left behind, and the gray is my original part. I apologize for my graphics card not being the best to show this, but when you have a deviation like this on curved surfaces, you're getting the same concept as it being finished within 3. So now that we kind of did this first op here and we roughed out our part, actually we did a lot of finish work in one swipe around too, I'm going to go ahead and start to add some more features here. So tool pathing externally versus internally in Fusion is very simple. So if I was to say I want to do turning profile rough, I could change whether or not it's outside to inside profiling. But like I told Greg, is we do have that fancy new mill turn machine. So let's go ahead and start adding some mill turn tool paths. We can go ahead and start with a couple basics, one of which might be a drilling operation into this part. So I'm going to simply say drill. I'm going to go out and find whatever spot drill that I may use. I'm going to look at one of my mills here real quick and see if I have anything. Maybe my other mill has something, not so much. My shop crib doesn't have any. So last but least, I could always go scrub some tool vendor catalogs as well. So the neat thing with Fusion 360, I do know that there's not a spot drill in this category, but I did show this to Greg. So I downloaded the entire Helical Solution end mill catalog. And now in the event when we get into milling, you'll see me simply come in here and say milling. I want maybe a flat end mill. And then lastly, my diameter on my end mill, I could say equals to 0.5. And you're going to see as I do this, how many tools populate that's a 1/2 inch helical end mill. So I have the entire catalog built inside of here to be able to search by their part number or to be able to find a tool that works, then look at their speeds and feeds from their tool library. So let's go back in here to the Fusion 360 library. I'm going to say instead of a ball end mill, let's go hole making. I want to use a center drill, or actually I prefer spot drills personally. And we can narrow this down again to see what size it is that we need. So give me a minute to open this up a little bit. And I like usually a 3/8. Another thing you're going to see here is I have a lot of different speeds and feeds tied to each tool. You can tie as many speeds and feeds as possible into what you're doing. I have a specific customer that runs a lot of K500 material. They have about 3 different speeds in here, all relating to K5. One could even be finishing versus normal drilling. There's a lot of different options you could do with this. So I'm going to go ahead and grab this drill. And then here's the fun part of being able to do drilling inside of Fusion 360. I can go ahead and pick that face. And what you're noticing is it actually lines my tool up perfectly with that face. One thing I also am recognizing here, Greg, is it looks like those angles on those holes are not a 90-degree countersink, correct?
I need to measure that, but yeah, it looks like it's a little, it looks like a little narrow.
It looks a little off. The good news is the customer okayed us to use this in the event that I did change my tooltip angle.
So Phil reached out to Casey, who confirmed with the customer that this is an acceptable change.
Correct. So that's where the nice thing is about giving feedback on a part before you take it. In part 1, you'll actually notice on this part, Jason, although he is a great designer, gave me a very nasty groove along this face and opened up these holes here. And with that, there's no way I'm going to hang a tool 20 times out deep and expect a good surface finish to do so. So with that, we're going to go ahead and move a little further here. I'm going to say select the same size holes. And as you can see, it automatically picked up all 3 of those holes for me. Lastly, I could change a few extra things here, one of which is I'm doing a drilling. I could do a chip break if it's something of your nature. We'll go ahead and add some of that stuff in as we get going. So I'm going to go ahead and say, okay, let's pull a dimension for this through hole. Correct me if I'm wrong, Greg. Is it so that I get ±5 on a part without critical dimensions?
Yeah, so Xometry has a manufacturing standards page. It's something you can also look at through our partner guide. Excuse me. And when you do not have dimensions on a part, we don't have a drawing with your part, then we are holding you to those general dimensions and tolerances. You will need to provide what you'd probably consider in your shop a IPI, an in-process inspection, or a final inspection report that you could generate. I know we'll show some cool 360 tips on that. And that's for our documentation. So say it does come back, we hear something from the customer, we could go and look back at that digital workflow and the documentation that you uploaded to verify dimensions and reporting on that.
Awesome. So that being said, I do have another template that's kind of a neat system here. So we know that's a 156 hole. Let me go ahead and pull in a drill bit that's 156. I do have a template, and what this template actually allows me to do is to auto find holes based on the drill size. So if my drill size is within a certain tolerance of my actual hole size, it will auto define those holes for me. So you can see how I picked a 157 drill. It actually automatically found those holes on my part. How this is being done is instead of using the ability to select faces, I actually found a way to use diameter range. Well, with diameter range, I went ahead and wrote an expression here. This expression is predictive text. So in the event that it did get deleted, this happens from time to time, I could start by typing in tool. And in this case, I'm going to go underscore and scroll down to diameter. And I want to take 3 thou undersize. So I'm going to go -3 thou inch, and it's going to give me my lower threshold point. I did the same thing for the upper threshold point would be +3 thou of an inch. And as you can see, it actually pulled all 3 of those holes. A neat thing I could lastly do is in the event that I want to work in a certain area, I could give that a specific boundary area and it will automatically narrow down to just one hole. Few other things I can do here looking from a side profile. This was originally designed for a hole bottom, or a bottom hole, not a through hole. So in this case, I want to go through the bottom and I want to give it roughly 50 thou breakthrough. Because I am drilling so deep, the last thing I may want to do is switch over to a chip breaking or a pecking cycle and say, okay. I'm going to add one more tool path before we get into simulating this. Let's go into full-blown milling operations now. I'm going to use...
And Phil, just real quick, because I think some of the wow factor is you have found features on this part, like the countersink and the drill holes with a step upload that you've never seen before. It doesn't have the parametric data. It doesn't say hole drill at this diameter. It doesn't say all this information. It's just detecting it. And I thought that was something that was a wow factor when Jason was showing me on the design side, what you could do and modify on the part when you don't have the previous information, like you got that CAD from a supplier or it's a legacy CAD. It's a part that you're looking to get made again, but the last time it's been made is 11 years ago. It's just really amazing what 360 can pick up so intuitively, and honestly, it is a wow factor for me.
Correct. It definitely does make your job a lot easier at the end of the day, by all means. So from here, I'm going to go ahead and throw another template at this. This template here is kind of my adaptive template. First go around, I'm going to go ahead and just hit regenerate so that we can see the results that happen here. You're going to notice that there is some extra noise going on because it's roughing the outside of my part, as well as doing that inside cavity. I can go in here and I'm going to edit this real quick. We're simply going to say, I want to do rust machining from previous operations and hit OK. So now Fusion 360 is looking all the way back at everything we did prior to, and now it's noticing this notch here to be able to machine that area out. We may want to avoid that to save cycle time. So let's go ahead and go back and edit this one more time. And this time, let's give it a boundary. I'm going to cheat the system and I'm going to say I'm using the silhouette of the outside of my part. And I want my tool to stay inside that silhouette, and OK one last time. And now you notice I'm actually just boring into there and roughing that area out. From here, I like to simulate my part and take a quick glance and see where we're at. I'm also going to speed this up. I'm going to turn on a collision checker to make sure nothing happens as we go and that there is no collisions with my part. So again, we do have those 3 spot drills. I have my 3 peck drilling cycles. And lastly, I do have that roughing cycle to go in and rough machine all that inside out. Because I did use a 3D adaptive, it did avoid going in and machining that lower radius inside of my part. So I'm going to repeat this a few more times as we get moving here. I'm actually going to do what's called a derive this time around. Derive allows me to actually pull information from one tool path into the next. So what you see is my silhouette came through my tool center on or inside boundary. I also want to keep this zeroed out inside a boundary. And then I'm going to go ahead and say, I want to work from my model top inwards. And the reason why is I want to try to avoid this top surface since we turned that top surface. I did get a little bit here recognizing that, so I can go back and edit that out. The horizontal tool path is great for being able to go in and clean up any flat areas inside of the part. Again, we now cleaned up the floors here. Lastly, I want to go back and machine this wall and this radius and add it into the feature, as well as possibly machining this fillet here. I could, yes, bore this out with a tool by all means. I did show you guys some lathe tool paths. I'm just showing you milling as if we had a mill turn type operation. The neat thing with this is if I switch to normal milling, we're going to copy a lot of these tool paths over. So
that's something we were practicing with. Was, is this going to be a mill turn? It's going to be a turn part here. But say your mill turns all of a sudden at capacity. You can just as easily say, all right, we're going to 3-axis this, and you don't change a thing. You just change the setup and into a 3-axis mill, and boom, you're already ready.
Correct. Yeah. So first time round, I'm going to go ahead and let this tool path do its thing. It's going to be a little tricky for you to see. So let's get another inspection tool out here real quick. What I want to do is split this in half based on my origin. So let's split my part this way and take a look at that tool path a little more in depth. So you do have the ability to turn these analyze tools on and off as you go. And in this case, I did pick a chain on my part for that tool path to machine to. So we're not quite going all the way down to the bottom of my part. I can fix that with several different tools inside of Fusion 360. The one I'm going to use specifically is changing from contour to a selected face. And now I could pick that lower face and hit OK. And you're going to see how that tool now goes all the way to the bottom of my part. Again, very nice feature for being able to clean up the bottom of that surface without running into any problems with machining. Let's get this analyze out of the way and let's get into a couple other things here. Ideally, since I have the bowl end mill out, let's do a little fillet cleanup on this inner fillet. So I'm going to go ahead and jump back into milling. Let's use a 3D contour toolpath. This does come standard in Fusion 360 for free. Everything I have done up to this point is the cost of just a standard license. Nothing is an added feature. So you do get things like the 3D adaptive clearing, 3D toolpaths all in one. I'm going to go ahead and say, let's do a selected boundary this time. And that boundary I want to do is actually chosen right off of my model directly. So this is one thing that used to drive me absolutely crazy when programming in other software, is the ability to create a geometry chain on my actual geometry. I don't want to project stuff into a sketch and circle back and forth to keep going with this. I could simply pick that right there to go around. Lastly, I'm going to change my maximum step down to roughly 10 thou. And one thing I did forget, and I'm going to circle back here, is my current boundary is tool center on boundary. That area is so small that my tool would actually not calculate a toolpath. But I can turn on what's called contact point boundary, which will shift me from the center of my tool to the center of radius engagement. So I'm going to go ahead and hit OK. And what you're going to notice here is it gives me this nice 3D toolpath to wrap around inside that part. Moving a little more forward, we do have some cleanup that we need to do in this area here. So I'm going back to another milling operation. Let's say a 3D adaptive clearing, move down to a smaller end mill in this case. And let's see what I can pull out of my library that I already have. We should have, I'm going to go with a bowl nose again and something about an 1/8 inch. We are going to do some aluminum roughing at first. So I'm going to utilize that tool path. And I could use rest machining if I like. I just prefer usually to do a selected boundary again and to pick that boundary based on the geometry of my part. Greg, how's this all looking for you so far?
It looks pretty good, and I also want to use this time to just bring in some questions. I know we're about 10:15. If we go a little over, that's cool with me, because I think I'm always happy to talk Xometry and talk machining. And I'm intrigued right now. But you're building this up. We have actually, because this has that surfacing aspect to it, you're probably selecting more edges than what you would do on the other side, which is mostly mostly you could do with a flat end mill. But no, this is pretty cool. I'm going to give a preview of a question, Phil, just something to bring in here, because there is always this question. I'm on the Xometry job board. I see an opportunity. Sometimes the opportunity just makes sense. Especially as you start working with Xometry, you have the sniff test. Like you look at something and like, I've done work like this before. You maybe see a higher percent score there. You look at the price, from your prior work, just giving it a 3D spin, that you have a that you're able to like say that's a good price for my shop. Boom, I'll take it. Again, once you press go, you are responsible for that quality and lead time of the part. So it's really important to make sure that you're not overextending. There's always going to be work available. So if your shop's really busy, but you do not need to take that work, there's no obligation to take it. But once you say go, that is your purchase order. That's where you're being held to. There's questions though. Something's a little bit more complicated. How do I check? Like, how do I give a quick sanity check for a part to see if, like, hey, is it really complicated, or does it just look complicated? Like, how do I know? Like, how do I do a quick estimation using this type of tool?
Correct. Just like you said, there's a lot of different ways around this. And I know we are slowing this down for a lot of people, but at this point, we more or less do have this one side pretty much wrapped up. So I'm going to go ahead and simulate this one more time. I could already think in my head, there's a little spot that I do need to fix after the fact, which is another horizontal tool path in that small little pocket. But what you're going to actually see here is the part turned from one way, and we're going to go ahead and flip this part over and start machining back the other way. On the idea that it could be a mill or a lathe again, I can bring all that information into Fusion 360 and use that to my advantage. So now you can see my smaller tool path coming in. I'm now cleaning up my walls and my floors, and that little nastiness all the way down there, I may need to trim out. We are going a little further than expected. And then there is a little flat here that I may want to clean up in between those two. I did notice on the part that Greg did so happen to get supplied to me, they did use what is called a scallop tool path. It is a very powerful tool path. A lot of you should be familiar with this if you do 3D work. It also does a great job with that. So flipping this part over and now basically machining back the other way, I could simply duplicate my operation that I have here to flip this part. And with that, I'm going to go ahead and take out a good amount of these tool paths. So the first one, as you can see here, before I do that, I do need to flip my operation. So we're going to go ahead and flip my Z back the other way so that I can machine this way into my part. I could adjust my stock and everything for visual purposes, but as if I flip this part over, I do have that first operation out the get-go. I'm going to go in.
So now you have the cylinder, you have it in a vise, or you have it in a chuck because it's still going to be on your turn machine, your mill turn machine.
Correct. So either my mill turn machine, or I could take this out and do milling, and we're going to go both avenues of approach here. Profile roughing, I'm going to say delete. We're going to go ahead and delete my outside. I already parted this part off, and now we're getting into some of this stuff. Well, I do have this nice little spot drill guy here. Let's reuse that tool path. Instead of those hole faces, I'm going to pull this hole face, and I'm going to simply say I want to go to a chamfer width. Again, this is the extreme laziness or proficiency, depending on if you ask my wife or my boss. I want to deburr these inside edges very quick. So I'm going to add a 20 thou spot drill, and it's going to go in and actually spot drill the backside of those holes in chamfer. Diving a little deeper here, we already drilled this, so let's hit delete. My adaptive tool path is one that I do want to keep. So let's go ahead and edit this. And this time I'm going to go ahead and give it a boundary that's selected. And I want to use this lower chain here. I want my tool to be inside of this, or I could say tool center on boundary. But what's going to happen is it's going to rough its way in and remove all that material. Also, I know that stock there is my turn profile. So I'm going to go ahead and pick that face there. And you're going to see this rough out that part. Looking at it now, boring down into the center might take a little bit too long. Let's flip this out to say tool outside of boundary and go okay. And now it's going to work outside in for roughing out all that material. Ideally, the horizontal, a great tool path again that I'm going to steal. This time we'll go ahead and turn off our silhouette. I'm going to just say no boundary and hit OK. And what you're going to see is it's going to actually clean up all those flat surfaces around my part. Lastly, I do have another template here that I could steal. This one I call my 2D contour. What this guy is going to do is actually find all the vertical walls here and clean up those walls. I am going a little deep on this tool path, and I am doing like a helical entry, two things that I don't want to do. So let's save some time here real quick. I'm going to first off only go to a selected bottom. So I only want to machine down to here because everything else is turned. The next thing I may want to do is instead of profile ramping, I can plunge and do a no contact position, and I could actually plunge down to each one of those areas without worrying about what's going on. So in this case, I cleaned up that part a lot. I actually added some time on my machining and able to go around all those features. Another thing I can do is drag and drop this program up and continue down with what I'm doing. 2D contour is no longer needed because I did clean up my walls and my floors. The last thing here is another contour toolpath for a 3D feature I don't need. And stepping down a little further, I'm not using that smaller end mill anywhere on those parts. One of the final things I may want to do here is now thinking about with spot drilling that area, what about being able to chamfer my edges so I don't have to deburr this by hand? I do have that feature in Fusion 360 to simply say I want to do a 2D chamfer. I could pick the lines that I want to chamfer and to break those edges with that tool. One other really neat thing that I can do here with this feature is I can utilize the entire chain segment and auto program in clearance on the edge of that tool. So let's give everything a 10 thou chamfer to save us time. In this case, I don't have a speed tied to this tool currently. However, it will still give me that tool path for machining purposes.
And I'm a huge fan. I think everybody, people who get parts are huge fans of machine deburr. So it's just so much of a consistent experience. And I've personally had experience where I saw a very specific scientific application that we were making a part for, and they said definitely do not machine deburr this internal edge. And it just kind of racked our brains. We're like, why? And we asked them why, and it's because it's not that the machine deburr is bad. they just didn't want someone to do manual because it got such a rough edge on it. So once we showed them what that looked like, we're like, here's what a 20 thou deburr looks like with a machine. They're like, oh, that's awesome. It's more consistent than the product that we received before. Yes, please do that. And we were able to change some minds there because just how consistent that experience is. I think something that Phil's showing here too is, we're putting in some finishing passes and things, and it's worth the 5 extra minutes of machine time to just run some finishing passes. Yeah, the look of the parts is just so much better, and the tools that you have to do it are probably the same tool sets that you already have in the machine at that time. So it's just a little bit of finesse. It's just like packing a job at the tail end to make sure that it has some extra padding so it doesn't get broken on the shipping side. It makes all the world of difference with barely any extra overhead.
So one thing a lot of you are seeing is a collision there because of the material on the backside. It does think that it is still there when I simulate both sides simultaneously. That is one thing I could have adjusted in my setup. And we also do have what's called continuous rest machining. That is a feature that you can turn on inside of Fusion 360 to auto recognize that area. I just want to give you guys all an idea of what this part looks like as you keep going with machining and some of the neat features that you have once this part is machined out. So again, right there, I did get a collision in that controller or in that corner, as well as colliding with my part directly. I'm going to pass over these and speed them up a little bit so that we can get through this and give you guys a good idea of what this part looks like. Greg, what are we looking at for time right now?
Let's give ourselves let's clean up real quick here so we can run to Q&A. I think it's time to jump in. I see a couple questions. I know that I've also seen Jason Casey answering some along the way. But if you have your questions, this is definitely a good time to keep on asking them. And again, we're happy to talk both the 360 side as well as the Xometry experience here. But this is really cool.
And Greg and Phil, I've selected 3 questions for you for when you're ready. So just let us know when you're ready.
Phil,
Awesome.
do you want to continue? Do you want to finish up the program? Maybe we could do some parallel, Jason. I think that could work.
All right, great. Actually, the very first question is going to be for Greg. So when Phil was showing the website and the jobs that were available, there was an option there to be able to preview the geometry that you're going to end up machining. In that preview functionality, are you able to take measurements of different radii or diameters or things like that?
So yeah, on that 3D view, you're able to do a few simple functions like a section view, and you definitely always see the XYZ up front. That's just like it helps give you a mental picture of the size of the part there, because it's sometimes you see a part, you're like, oh, that's simple, and then you realize the longest feature on it is like 0.22 inches, and you're like, oh, hold up, and you have to sharpen your pencil to make sure that it fits your machine capabilities. There are measuring tools on the 3D viewer. We are updating them constantly, so that's something that I think we're making it more robust on that side. So things like distance measurements, hole measurements. So it's if it's not there right now, it will be available very soon.
Excellent. I have another question for Greg. So someone was talking a little bit about estimating costs. So when you're doing your cost estimation on your side, you're giving a single price for the customer, regardless of which machine shop is going to end up making the final part. But those machine shops, they would likely give their own quotes that may differ from yours. So can you tell us a little bit about how you're getting to the pricing that you're getting to? And in particular, as kind of like a follow-up to that, please keep in mind that their cost that they would charge the customer might be higher. So try to frame this to like, why is it still worth taking these jobs, even if the estimate is a little bit less than they might be otherwise getting if they were talking directly to the customer.
Oh no, absolutely. That's a great question, and it's definitely a little bit of a paradigm shift because one of the things that we're utilizing is kind of Phil mentioned before with his shop. You could use this for 95% of all your revenue, or you can use this for 5% of your revenue, whatever best fits your shop and its capabilities. What you're getting from the job board is work that is won. So that means that we've already had business development, acquiring that customer, getting them on board, working through any NDAs or any vendor forms that may just be a hard stop for you as a smaller shop, like working with companies like GE, Bosch, Dell, NASA. some companies that have very high vetting processes, and we are assuring that quality for them. So this is why quality assurance is such a big deal for the Xometry manufacturing network. But the work that you have is that what you're being able to do is say, immediately I could get a revenue stream. I don't need to search for this customer. I don't need to find them. They may not have never been able to find me just because of geographic location, but now I'm able to access this work on demand. The way that we price is actually based off the marketplace that we have. So these 5,000 manufacturers, 3,000 United States, we pay our manufacturing partners, and so we know the costs of parts based off their materials, features, finishes on a open competitive marketplace. Shops that like this type of work tend to take this work at this price, and we use that to train actually AI machine learned algorithms to create a cost model and that's what the customer sees. So when the customer puts up a geometry that has never ever been created, brand new geometry, as soon as it's uploaded, it gets an instant price. And that pricing is again based off this feedback loop between Xometry storefront and what the customer's purchasing for, as well as our marketplace suppliers, so the folks that are taking work on the job board. So it keeps us honest. And honestly, I think one of my supplies leads said it best, like, we have skin in the game with you. We're not tossing this over to you. We're here to make sure that the work goes successfully and that we get more work from that customer and we're able to provide more work for you. So we're in this together.
And Greg, if I could just add one more point to that, which is that Xometry itself still has to be able to profit from creating this marketplace and spreading that marketplace so that it's going to be as big as it is. And so part of that profit is going to go to Xometry itself as well.
Yeah, absolutely. And like I said, there's a delta there, but that's part of our business model too, right? That's how we're able to grow and get even larger. And by the way, I saw Ryan actually reached out with a great comment, which is I'm really happy that you're a manufacturing partner, but said this is fit our shop especially for the reason. So that reason of being able to get work that you just may not have access to as a smaller shop. Having that direct connection to more complex work that you may be best in the world at making, but you just may not have the business connection to get to, is something really cool about being a Xometry manufacturing partner.
Excellent. We have 2 questions for Phil. Are you ready for questions, or are you still programming on your side?
Oh, no, we're good to go. What do you got?
All right. First question is going to be about in-program generated inspection forms. Can you tell us a little bit about manual inspection in Fusion 360?
Yeah, so we just actually released about a month ago one of the coolest things I think I've ever seen in Fusion 360. You can go into the inspection tab on your normal license and you can create manual inspect. So in the case of this part directly that Greg did send us, and there was no print, so it's kind of hard. I have to create my own inspection. Normally, a lot of people use an Excel spreadsheet to do this. You use a micro height or something of that nature.
Mm-hmm.
I can actually generate this information directly here inside of Fusion 360. I can also incorporate tolerances. In this case, I'm going to stay a little tighter than Xometry to give me that buffer. Greg may tell me that's a no-go, but at the end of the day, as long as my part's good, it's good to go.
If it's tighter, it's okay, but we give plus or minus 5 for distance tolerances, so don't sell yourself short either. Yeah.
So in the case of this part now, I do have 2 inspection points set. If I was to spend the money on the fancy Bluetooth calipers out there on the market, I can actually automatically have this process happen. But if you're like me and you still use a good old set of veneer calipers, I can actually type in the dimension I'm getting on my calipers. So let's say this actually comes out to 1.390. You can see it shows me a deviation, and it also tells me right here that I'm good. So I don't have to look at the print, go back and forth a couple times, second guess myself. The same thing would happen is if I say this comes out to 1.450, I now have an error deviation of 6 thou. So I'm actually out 10 total, but I'm still 6 thou out of tolerance. Well, hopefully when you guys go to do your parts, they come out good. The final step of this is I have the ability to export this as a inspection report. So in this case, I'm going to go ahead and create my inspection report for my Xometry website. Give me 1 second here to create this. My brain is drawing a blank at the moment. I apologize to everybody out there. Give me 1 second to do this.
Well, while he's downloading this, because this is actually really cool. It's really important for Xometry as well, because we do need an inspection report. And this is a perfect way of integrating that inspection and making it easy for you so that you can export and upload to our inspection report documentation on the Xometry partner page. We do require that inspection report as well as some photo images of the part. So if you go to awaiting file uploads there, you can see on the bottom right there, photos and inspection reports. Bottom right.
Yep.
There. Yeah, this is where you'll put that in. We also have our partner guide that has all the criteria that you possibly need to understand what the inspection requirements are. So, if a customer asks for a formal inspection report, that's a deliverable. That's something that's folded up, placed with the part, and delivered to the customer. Definitely the same for like a CMM or AS9102 style report. Those are all ones that are deliverables. Same thing with material certs, COCs. We need the digital file attached with the part itself, but we also those things are going to the customer as well, so they need to be in your box, and you'll see that on the shipping checklist.
Phil, I have a little follow-up on that same topic. So this manual inspection is for you to go and inspect this part manually, whether you're using calipers or a CMM or something like that. What if you happen to have a Renishaw probe in your machine? Would that also work?
Yes, so we do have a Renishaw probing system inside of Fusion 360. The most common one that is a standard feature is Probe WCS. So if you're like me, you do 5-axis work and you don't constantly want to have to go in and manually probe, as that part moves around from loading the next part, we can auto probe your WCS and change your coordinates every time. A more advanced feature that we do have that is a part of our extensions is the probe geometry. This is a whole nother world of using your probe. I know, for example, you buy a new machine, you spend $5,000 to $10,000 on that probe. Well, probe geometry now allows me to measure the part on the fly and auto adjust my tool wear and things of that nature. And if you're somebody that does very organic shapes or molds, as I've done in the past, we have what's called Inspect Surface. This will actually turn your machine probing system almost into a CMM so that you can create point cloud data, bring that back to Fusion to see it in real time. Some of you out there probably already know the golden rule. You should never use the inspection report from the same machine you machine on. So I like to say this is a guarantee. So instead of me taking a part out of the machine, taking it to quality control to CMM it, they tell me it's wrong. I go back to my machine. If my probe is up and calibrated, I should be able to pull very precise information and see something like maybe my surface is all off by 10 because I forgot to do a finish after my pre-finish.
Yeah, it's an insurance policy. I will say, so it depends, and I think we like those on a case-by-case basis on what type of measuring tool you may have. I find that I'm even finding we're in the future now. I've seen a lot of laser profiling systems that are coming new that are actually pretty amazing and pretty accurate at reporting back. That being said, you do need to be able to at least provide a report if a CMM is requested by the customer. Provide a report that feeds back to their dimensions and measurements, so those GD and T dimensions and those other features. So if you do have an inspection system that can do that and it's calibrated and you can provide proof of calibration, that's go, right? But if you're using it for verification, but it can't do things like true position or a surface profile and measure to that level of detail, then you'll need a secondary inspection method.
One other thing to keep in mind too, we did just release this as well. It is in our preview feature. It's called part alignment. So one thing that may drive you mad, and it's driven me mad, is you bring in a mold and it's a mold that you're doing a revision on. So we already have a pre-created part. And let's say it started out as a casting. Well, I need to align this to my machine. Yes, I could get the dial indicator out all day long, but if I don't have a square edge to work off of, I'm kind of in a different location. So maybe I probe a couple points, try to do that in Fusion. Part alignment is an automatic procedure where you go to your controller, you probe the features of your part, you bring that back to Fusion, and it will actually automatically adjust your post-processed program to reflect those dimensions. So no longer do you have to spend several hours aligning in a part. We could actually just, not to say throw it in the machine, but you can get it in there close, and then you can go and do a part alignment, and we automatically do that stuff.
Great. And Jason, I think we have time for maybe a couple more questions, and then we can always follow up after the webinar as well.
I have the very last question. This one is also for Phil. We have a user, Jeremy Abbott, who is using HSM Works. And HSM Works, of course, is the same like kernel or like brain behind Fusion 360 CAM, but inside of SolidWorks as an add-in. And he's noticing that a lot of the new functionality is coming to Fusion 360 and has not yet made its way over to HSM Works. He wants to know in particular when he should expect to see some of those new features coming from Fusion 360 over to HSM Works itself.
So to dive a little deeper on that, the kernel behind Fusion HSM Works and the kernel that drives HSM Works in SolidWorks is very similar with a lot of those features. However, a lot of these real high-end features you are starting to see are coming from kernels that PowerMill and other softwares use. I cannot give you a definitive timeline. We do have a blog online that you're more than welcome to look at to see the timeline on what's being operated and what's happening to move things into SolidWorks. If you are wanting to get into things like the extension and the advanced features with your HSM license, you do get a license of Fusion 360 as well. So you could use your normal Fusion 360 license for that advanced stuff. Jason, did we get any other questions here at the last couple minutes?
A few just popped in. Hold on just one second. I'll get you those questions.
All right.
All right. Edmund wants to know, it's more about the inspection again, actually. If he has a repeat job that he's doing over and over, can he save all the inspections for all the different parts or like the serialized parts?
Yeah, so
to
dive a little deeper is I just created this inspection report based on this these inspection points, created this report. If I wanted to say this is serial number 001, for example, that's a terrible example, but I could say serial 01. And then when I create a new inspection report, so I record them the second time round, we'll say 1.3 and 1.4. Now you can see I have a second inspection report here. So now this one could be serial number 010 for that go around. And you could do this as many times as you want inside of Fusion 360. At the end of the day, I would still save that inspection report as a PDF and back it up somewhere else. That way you don't have 100 reports in here. I could actually start to clear this out or regenerate some.
Yeah, and by the way, on the Xometry job board, this is something where you could upload as many inspection reports or files. We have a standard sampling plan that you could look up, but it's like the ANSI Z. I'm gonna mess up the numbers there, but it's a very standard sampling plan for most inspection facilities. You can see that lookup table about how many you'll need based off that, based off like the quantity you're making. And something important to say is if there is a repeat job, because I know that question was, hey, I do serialized production and I get different orders, but it's all for the same part. We do have what's called exclusive offer for repeat work. So if you accepted this job and you just made 5 of them in 6061 aluminum, and then Jason's like, this is great because I need 50 now. As soon as they press, as soon as he presses buy, you get that offer. So if you did that job, you're going to get that work directly and essentially have an exclusive period to take that work. That being said, if you're like, hey, I'm a job shop and I don't really want to make 50 of these, we still have our competitive manufacturing marketplace to take on that work. So there's still redundancy built into the system, but we want to make sure that if you've already done the tool pathing, if you already have the tools, if you already have the setups, like, yeah, let's make make more out of this here, and we give you that option.
No more
Awesome.
questions from the Q&A, so you guys are good to close out.
Awesome. So I'm going to go ahead and move on to my next slide. And I would like to thank Xometry directly, as well as Greg. They partnered with us for this whole series. We wanted to show several different workflows and how we both integrate and work hand in hand with whether it be your design or your manufacturing needs. Ideally, Jason was a great person in part 1. That video link he did post in the chat channel if you want to go watch that. You could also search it on YouTube directly, but it does show you both sides of the fence. If you're like me, you always question how it got designed. It's a great example of how something like this gets designed. With that, Greg, do you want to go ahead and add anything?
I just I sent a link out there for the xometry.com/partner-network. You can also just click at become a partner at the very top of the page on xometry.com. And just note that we do this manufacturing for manufacturers. Excuse me. So if you are a manufacturer and your company comes to you, your favorite customer, and all you do is 3-axis milling, they come to you with a mill turn part, or they come to you with a sheet metal part as part of this larger bid package, and you want to win the work, you could always go and use Xometry to quote that part of the work that you're going to outsource. And we'll make sure that we assure your quality and get a timely delivery for you, while you could take on other work that best fits, so you can win that total package. And we see that a lot. A lot of our best customers are manufacturers. And Phil, so I hear Fusion 360 is a cool deal right now.
It is. So if you have any questions pertaining to Fusion 360, you guys would like to see a more customized one-on-one personalized demo, I always challenge people. I say, myself as a tech, we have a team of 5 tech specialists that want to see what it is that you do and show you how we would do it inside of Fusion 360. And to do so, you can reach out via Fusion 360 demo at Autodesk.com. I believe Jason is probably copying and pasting this into the chat channel. We will leave this open for a few minutes longer as well, just in case anybody needs to get those links out of the chat area or want to ask any more questions. Actually, I did just see one more come in, Greg, and I know exactly how this guy feels. This is one of my favorite questions. Is partnership available to people with machines in their garages? I can answer this on your behalf, Greg.
Okay.
So it is completely possible. It is a little tricky to get approved, and you have to plead your case. In my case, no website. I'm a guy in a garage. My address goes directly to my house. All of that stuff. I became a partner through that process. It's just a little longer of a process than what it is normal, because you're not quite a full stand-up business.
Yeah, and I think that's good. We because we have the customers, like as we mentioned before, a lot of our customers are defense, aerospace. We have, Dell, Bosch. These are the ones I can name. That's why I keep on saying them over and over again, because we keep client confidentiality very, very serious here. But we've done case studies with those folks. They have receiving inspection, so we need to have receiving inspection. A lot, we do work on demand all the time. So for example, like parts are not dropped off to FedEx Kinko's. They are picked up directly by FedEx, or they're dropped off at a FedEx facility. There's certain things in the workflow that become sometimes difficult if you're running this more on a hobby side. But as Phil said, if you're taking it seriously, you're sharpening your pencil, you're working to make parts to spec on time. Let's have that conversation. You'll have to make more of a case, but we definitely have those on the network. And I'm trying to find a great case study that our partner team did. But if I find it, I'll send it out to you, Phil, and that's something you could share.
Yeah, I mean, on my personal account, even though I did Xometry work, or Xometry, sorry, Greg, Xometry work through my normal day job, I did 2-axis lathe work out of my garage for Xometry. Realized, when it does come to those higher inspection problems, things like that, I basically took on bushings, used a set of calipers and a micrometer, and it worked out great for me. It was just a little bit longer of a process to get approved. That's all that I have to say on that.
Awesome.
I don't see any more questions here. I believe at this time we should have had a good amount of people grab the links that they needed out of the chat. So we're going to go ahead and close this out. Again, if you want to reach out to Xometry directly, or if you want to reach out to Fusion 360 sales team, feel free to do so, and let's get you going.
Guys, thank you so much. This has been great. Take care, guys.